Okay, class, time to start. How many are there? 50. Time to start, guys. We'll get going now. Firstly, any doubts in the first two questions, guys? The first two questions, everybody's done. I know many of you have done more than that. But if anybody has any doubts in the first two questions, let me know. Otherwise, please complete the next two by tomorrow. So that if you have any doubts in question number 3 and 4 of dry docking assignment, I can address them tomorrow. So I'm just going in small steps so that everybody is able to keep the pace. Those who have finished all, that's fair enough. That's okay. So any doubts, guys, on the first two questions? I presume none, right? Right, beta?
सर आंसर आप मैच करने
First
थे क्या?
two,
Answer मैंने कल क्या कहा
first
था? I said I do. What did I say in the class yesterday? That I don't keep answers. People are posting. तुम्हारे answer match हुए नहीं हुए? तुम बताओ पहले. So many people have posted answers on the group. तुम्हारे match हुए नहीं हुए answers?
सर
हाँ
फुल
भाई.
मैच हो रहा है, कोई सा नहीं हो रहा.
कौन सा नहीं हो रहा? फर्स्ट एंड सेकंड में कौन सा नहीं हो रहा? You tell me that. Which part of first and second
सर
is not matching?
सर मैंने सारे कर लिए सर, मैं इसलिए
I am.
पूछ रहा हूँ.
Yeah, my discussion is limited to what, beta? My discussion is limited to first and second. Are they matching?
Yes sir.
बोलो भाई. So then let's put to rest for the day. Tomorrow, if 3 and 4 are not matching, then you let me know which one is not matching. Okay?
Okay sir.
Okay. So let's not unnecessarily. Today I start discussing question number 7 when people have not reached there, then it defeats purpose. It doesn't serve any purpose. So if 1 and 2 are done, then there is nothing to worry about. So guys, for tomorrow, question number 3 and 4 of dry docking, please. Now, before we start Simpson's rules, it's time to start now. I want to take you through the concept of moments, which is very, very important to understand. Because in Simpson's rules, it's the game of moments. Okay. And moments you know from school and you've been using otherwise also. When you calculate the kg of the ship, you take the moments. When you calculate the LCG of the ship, you take the moments. Only difference is when you calculate the kg, you take the moments about keel. When you take the LCG, usually in most of the books and ships, it is taken about after perpendicular. Do you agree with me, guys? Yes or no?
yes, sir.
Yeah, right. So, what is important? Let us say we have a ship here. Let us say the ship comprises of only 4 weights, let's say, or 3 weights. Why waste time? W1, W2, and W3. And let us say the weight of the ship's hull is negligible. That means the displacement of the ship is now nothing but W1 plus W2 plus W3. Now, if you are talking of kg, then you are talking about the distance of center of gravity of W1 from keel. This is called lever of weight 1, and we can call it as kg1. So what is kg1? Kg1 is the lever of W1 from the keel. kg2 is the lever of weight W2 from keel. kg3 is the weight of the lever of weight 3 about keel. Then we say, what is the vertical moment of W1? It is W1 into kg1. That means the weight multiplied by its lever. What is the vertical lever of the second weight? It is W2 into kg2. What is the vertical moment of the third weight? W3 into kg3. Is there any other weight on the ship, including the hull? None in our assumption. If we add all of them, we get the total vertical moment of the vessel about keel. And what do you do? If you assume the ship as one entity and you say the total weight of the ship is one body, Okay, it is distributed at W1, W2, W3. But if now until now I was taking each one of them as individual. Now they are all placed in one body. And now we are saying, where is the center of gravity of the body? Center of the gravity of the body is G. This is the lever of the COG of the ship from about keel. So the vertical movement of the ship can be obtained by adding these three, or vertical movement can also be obtained by multiplying W into kg. Since both these represent the vertical movement, we can equate them. And that is how you calculate kg by this formula, guys. This is how you have been calculating kg. Some of you may have realized what you are doing. Some of you might have just mugged it up and just going divided by W1 plus W2 plus W3. I'm sure all of you are familiar with this method. Yes or no, beta process? Yes or no?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now, in the same ship, if I take the levers not about keel, but if I take the levers about after perpendicular, then this becomes the lever of weight 1, LCG1. This is the lever for the second weight, where LCG2. This is the lever of LCG3. Tell me, guys, will W1 into LCG1 plus W2 into LCG2 plus W3 into LCG3, which will be the vessel's longitudinal moment. Do you expect the longitudinal moment to be equal to vertical moment, or you do not expect them to be equal? Do you expect them to be equal or unequal?
Unequal, sir.
Unequal.
Unequal. But you see, it's same ship, same weights in the same location. You've not shifted anything. They are where there only. But the longitudinal moment value does not match the vertical moment value. Why? Because the axis about which the moments have been taken has changed. Axis has changed. So guys, when you take moments, what is important is you have to identify moment of what. When I say what, these moments, we know why I have taken this example. We are all very familiar with it. Exactly the same way, we can take the moment of area, we can take the moment of volume, we can take the moment of mass, we can take the moment of weight, we can take moment of any of these physical quantities. Mass and weight we have just seen for kg and LCG. Similarly, area movements and volume movements can also be taken. Only thing is W1, W2, W3 will be replaced by area 1, area 2, area 3. And kg1, kg2, kg3 will be replaced by their levers from the reference axis. Likewise, for volume, W1, W2, W3 will be replaced by V1, V2, and V3. Have you understood what I said, guys? Yes or no?
Yes, sir.
So whenever you deal with the moments issue, you will ask yourself, you will not say, we'll calculate the moment. Now, this is an incomplete statement. Like when you say trim is 2 meters, that's an incomplete statement. Is it 2 meters by head or is it 2 meters by stern? That is the complete statement. Likewise, if you say, what is the moment of this? Now, this is an incomplete statement. Why? Because the moment you can see in the same ship, same weights. Moment about keel was different from moment about after perpendicular. If moment about forward perpendicular, the values will be altogether different. So when you talk of moment, when you talk of moment, you'll ask yourself this question: moment of what? Mass, weight, area, or volume? Once the answer is obtained, and which one? Which area, which volume, which mass, which weight? So first question you'll ask yourself is moment of what and which one? Yourself is moment about which axis. If you do not know the axis, then talking about moment is absurd. It's makes no sense. So you have to be wary of it. Once you get the axis, you will identify the lever. What is the lever? As you saw in weight W1, W2, W3, it was the distance of the center of gravity of that weight or mass from the reference axis. I'm using the word reference axis, which is keel in case of vertical movements, which is after perpendicular in case of longitudinal movement. In case of areas and volume, it will be the centroid or the geometric center of the area, the distance of the centroid of the area, or the distance of you'll get 10 questions back from me if you start telling me I have not understood lever. What is lever? It is the perpendicular distance. Guys, I'm not interested to rush with Simpson's rules. They are simple. Problem is with the issues. It is the perpendicular distance of, if you're talking of area and volume, centroid of area, volume, mass, weight. In that case, it will be center of gravity from the reference axis. And that is the lever. And you see, when the ship comprised of three weights, we could add all the moments and get the total moment of the ship about keel or about after perpendicular. Any questions on the class? Is it clear? So guys, suppose I have this, so I'm clearing the screen on which I have spent enough time. I'm clearing. If anybody wants to take it down or something, you can take it down. I'm clearing it. Now, guys, on the same lines as the ship's kg, suppose I have a axis, let us say y or whatever it is, or x or z, doesn't matter. Let us say I have two areas. Let us say I have area A1, whose geometric center is G1. And let's say I have this area A2, whose geometric center is G2. Now, if reference axis is YY, then this is the lever of area 1 up from YY. Likewise, this is the lever of area 2 from YY. Then I'm sure you will agree represents moment of what? Area 1 about which axis? About YY will be equal to A1 into L1. Does everybody agree with me? Yes or no?
Yes, sir.
A1 about YY will be A1 into L1, right, guys? Clear?
Yes, sir. Yes, sir.
Exactly the same way, moment of area 2 about YY will be A2 into L2. Now, if I talk of the combined area, which is the combined area, I'll run the blue marker on the total combined area. Now I'm talking of this blue area. The total area A, if blue area is A, we know A is equal to A1 plus A2. And now, what will be the vertical, what will be the moment of, if I add these, I'll get moment of area 1 plus moment of area 2, and this will be A1 into L1 plus A2 into L2. And since there are only two areas, this will become the total moment of A1 plus A2 about YY. Now let us say this blue area which is there on the diagram, let us say its geometric center is here. And let us say its lever is L. So using the full area, like the full weight of the ship, the moment of A about YY will be A area into L. Am I right, beta? Yes or no? Correct?
Yes.
Correct?
Yes, sir.
Since these both represent the same moment, in one it is the total area, its moment. In other case, it is the sum of the components of that area. Sum of the moments, the components of the area, both have to be same. Moment has to be equal to, sorry, A1 into L1 plus A2 into L2 has to be equal to A into L. So that means what will be the distance of G from the axis? It will be equal to A1 into L1 plus A2 into L2 upon total area, and total area is A1 plus A2. And this is what you exactly do for kg. Remember, guys, when you have to find the kg of the ship, this is how you find instead of area, it's the weight which comes into picture. Am I right? Yes or no? Correct?
Yes, sir.
So it is the same concept. Why I'm repeatedly talking of kg and lcg? Because you've been using it in and day out, and you have used it. You may know it, you may not know it, but you are using it. So if now you connect it to that, understanding it will become easier. Okay. So whenever it comes to question of moments, you'll ask yourself a question: kiska moment, whose moment, and about which axis? We'll try to write as much as we can write. But as I said, every time you cannot keep writing, which is the first point of contact, which is this, but you'll talk to yourself and keep reminding. I said, every time you write TA, TF, but you don't say, is it TA, TF of trim cost, initial trim or final? But you write TA, TF, but to yourself, you always remind TA, TF of what? Exactly like this. Every time I may not write the axis, every time I may not write the area or the volume, but every time I must remind myself which area, which volume, which weight, which mass, and about which axis. Is that clear, beta? Clear, guys? Understood? Understood,
Yes, sir.
class?
Yes, sir.
Now, the last thing before we go further, what are Simpson's rules? They will come in the thing also when we do. Simpson's rules is nothing but a simplified technique of integration. It's a simplified technique of integration. Guys, in the schools we know what does integration x dx means. It means x square by 2 plus constant. So our curves, if we have an area like this, in schools we had learned that we'll take an elemental strip of thickness dx. There will be equation of this curve. We'll calculate this area to be rectangular and then integrate within the limits, definite integrals. That becomes a cumbersome, tedious process. So what has Simpson's done? He simplified this technique of integration through the application of technique. So if somebody asks you what is Simpson's rules, it's nothing but a technique of integrating. Or, and what is integration? Integration is adding together, putting everything together, integrating together. You integrate the states of India, it becomes a country. So integration is nothing but adding, putting them together. That is what is integration. Okay. So it's a simplified technique of integration. Now, are these empirical rules, or these formulae, are they derived formulae? What are empirical formulae? Empirical formulae do not have a derivation. People perform experiments, they get the results, then they try to make a formula in which the results can fit in and be justified. They don't have a derivation backing them. What were mathematical formulae? Mathematically derived formulae, they are the formulae which have a derivation backing them. Simpson's rules are mathematically derived formulae. They are derived formulae, and therefore they have a derivation. And obviously, derivation is based on a different starting points. In one case, he has assumed the curve is a second degree curve, that is, it is y is equal to ax square plus bx plus c is equal to 0. You don't have to go that far. In the other one, it's a third order curve. Therefore, rules have given different results, and accordingly, there are three rules: 1, 2, and 3. Okay, you can use any one of the three. They all fit into our requirement. You cannot say whether which one rule will give you better results as far as naval architecture is concerned. And in the same scenario, if you use different rules, you will get different results. हम बता तो रहे आपको ये ना ठीक है मतलब Kundan, mute yourself. Kundan, mute yourself. So, so basically, they'll give you different results. What does it indicate? That the results obtained by Simpson's rules are not exact. They are good results, but not exact results. And they are good enough for naval architecture. Therefore, Simpson's rules are extensively used in naval architecture. So that is the background of Simpson's rules. Said, guys. Is it okay?
Yes, sir.
Okay. Simpson's rules are a convenient and user-friendly technique of achieving integration. Results are not exact, but reasonably good for the purpose of naval architecture. So hence it is extensively used in naval architecture. These rules are mathematically derived. We don't have the derivation as part of our curriculum, but derivation is quite simple. At any stage of your career, if you want to educate yourself, all of you have access to ship stability by Darits. If you open the chapter on Simpson's rules in Darits, you'll find the derivation. Okay? So if at any stage you want to go through the derivation, I've told you where the derivation can be seen. Now, it is very important that we understand certain terms when we apply Simpson's rules, because we'll be repeatedly using those technical terms. The terminology has to be clearly understood. What is it that we need to know? First will be ordinate. Second will be common interval represented by small h. Third would be Simpson's multipliers. Fourth would be Simpson's coefficient. And last would was the result. We shall first understand these correctly. What do they mean exactly? Now, what is ordinate? Ordinate is the input to the Simpson's process. If you manufacture something, there is an input and there is output. So to the Simpson's rules, what is it that you use as input and what is the output you get? Guys, just have your fingers in front of you, all the four fingers of your hand in front of you. Okay, just spread the four fingers apart. Now what happens? Each finger is separate. Assume that the thickness of each finger is negligible. So each finger represents a straight line. Have you done that, beta? Each finger represents a straight line. and you have opened them up. And let us say each finger has negligible thickness, so it's just a straight line. Okay. Now, if you put all the fingers together, now you have integrated them, you have put them together. What does it become? It becomes an area, yes or no, beta? If you bring your fingers together, all the four fingers form an area. Am I right, guys? Yes or no?
Yes, sir.
Correct. Suppose you take the matchsticks. Suppose you take the matchsticks and imagine that each matchstick has a negligible thickness. So each matchstick represents a line. When you lay all these matchsticks on the table, each joined to connected to the another, each placed touching each, and then you'll find these matchsticks occupy a certain area of the table. Am I right, beta? They will occupy a area of the table like this: one stick, second stick, third stick, fourth stick, fifth stick, and they will be occupying certain area. Correct, beta? Yes or no? Am I right?
Yes, sir.
So here, when you put the lines together, they result into area. So what is the input here? Input are the lines or the length, and the output, the result is area. Now look at the register or the notebook in which you're writing. Look at each page of it. Thickness of each page is negligible, but each page has an area. Each page has an area. If you put all the pages together in a book, the book has a volume. So what happens? When you put the areas together, they result into a volume. Am I right, Pita? Yes or no? Correct?
Yes, sir.
Right? So here, if I'm integrating areas, areas are the ordinates. If I'm integrating areas like the pages of your book, the area becomes the ordinate. And when you integrate areas, what do you get as a result? You get the volume.
Volumes.
If I was integrating the matchsticks together, then they were resulting into an area. So the line was the ordinate, length was the ordinate, and the resultant was area. Understood, beta? So what is ordinate? Ordinate is an input to the integration process. And depending on what is the input, you will have the output. Output or the result depends on the ordinate. Two cases we have already discussed. If the input is a line, ordinate is a line, output is area. If input is area, output is volume. So these two cases I have already explained to you. Up to this place, have you understood, beta? Am I right? Yes or no?
सर ये पेज की लेंथ वाला समझ नहीं आया सर पेज का एरिया इनटू वॉल्यूम डिडंट गेट सर
ओके, क्या बोल, जरा रिपीट करो, मैंने क्या बोला था?
सर रजिस्टर का पेज व्हिच यू आर सीइंग is giving an area.
It has an area. It's not
Yes.
giving an area. It has an area.
It has an area.
Does the page have an area?
Yes, sir.
Okay, then what did I say after that?
Combined together, all the areas give us the volume.
So does your book have a volume when they are put in a book and bound together?
Yes, sir.
So what does that volume comprise of? It comprises of all the pages put together, yes or no?
All the pages, yes, sir.
So what have you done? You put the areas together,
Yes, sir.
and the result into
Result into the
volume.
volume. Yes, sir.
Okay.
And depending and same. Yes, sir.
I'm unsharing the screen, guys, because I can't keep sharing the screen if I have to put on my camera. Okay, I'm sure you can see me. Everybody can see me. I have
Yes,
put
sir.
me on spotlight. Yes or no?
Yes, sir. Yes.
Okay.
Yes,
When I show you this page, what do you see? You are seeing it a line, this part of it. Do you
Yes,
see
sir.
this part as a line? Yes or no?
Yes, sir.
this edge,
Yes, sir.
correct?
हाँ जी सर.
You see the edge of the other line, and you see
Yes, sir.
when all these pages are put together, when all these lines are put together, they result into area. Yes or no? You have an area of the surface here. Yes or no?
Yes, sir. Yes, sir.
Correct? Right? But now look at it like this. Each page here, each page here is has area. Each page has a area.
Yes, sir.
Each page has a area. And when all these areas are put together, it results into volume. Yes or no?
All. Yes, sir. Yes.
Correct? So when
Yes, sir.
you integrate lines, they will result into area.
Okay.
When you integrate area, it will result into volume. Is that clear, guys?
Yes.
Clear, class?
Yes, sir.
Now, we can also integrate the moment of lines, like this ordinate. Now, best example is go back to the ship kg. When you are adding W1 into kg1 to W2 into kg2 plus like this, these were the ordinates because you are adding them. I said integration is addition. What was the ordinate here? Ordinate was the moment of the weights which formed the ship. Yes or no? Correct, beta? Am I right? Correct. What was W1 kg1? That was the moment of weight W1, which was only one part of the ship, one weight of the ship. What was W2 into kg2? It was the moment of the weight 2, which was again part of the ship. Like this, you could have 10 or maybe n number of weights, and each had a moment about keel. Yes or no, beta? Am I right? Correct? Class, do you hear me?
Yes, sir. Yes.
So when you put, when you add to, when you add together means what? Integration. You got the moment of the full ship, vertical moment of the full ship. Okay. And what was the full ship weight? Full ship weight was W1 plus W2 plus W3. So whatever was the total of W1, W2, W3, you get the moment of that. So what was the ordinate when you were adding the moments? The ordinate was the moment of the constituent. Now don't call it as weight only. It was the moment of the constituents of that particular physical quantity. Like in ship's weight, the constituents were W1, W2, W3, W4, W5, and so on. In an area, in an area, in an area, beta, what are the constituents? What are the constituents of the area? Tell me now. By drawing, you can, that gives you a hint. Line, lines are the constituents of this. Yes
Lines
or
are the
no?
constituent. Lines are the.
Okay. So if I take the moment of each constituent, like the of each of these lines, and add them, it will give me the moment of the full area. Yes or no? Why? The lines are resulting into area. If I add the moment of all these lines, will I get the moment of this full area? Yes or no, beta? Am I, tell me,
Yes, sir.
guys? If I take the moment of the lines, will it give me the moment of the area they form? Yes or no? Correct?
Yes, sir.
Yes.
Okay. Exactly the same way, if I take the moment of area of each page of the book, it is going to result into moment of volume of the book. Why? Because all the areas together form volume, so it will become moment of volume. So please remember, my ordinates can be the length of a line. If it's length of the line, the output would be area. My ordinate can be area. In that case, output will be volume. My ordinate can be moment of a line. Then it will be moment of the area formed by those lines. and it can be moment of area, then it will be moment of the volume formed by those areas. Have you understood? Any of these could be the ordinates, and depending on what is the input to the process, the output will accordingly change. Let me clear it and show it to you again. If you have any questions to ask, tell me, beta. Is that clear?
Yes.
Clear? Clear, class?
Yes,
Yes,
sir.
sir.
I'll continue explaining on this page only, and I'll not show that the next one earlier. So we had a couple of terms. First was the ordinate. We have already understood what an ordinate means. We have already discussed it. Second was Simpson's multiplier. Of a forecastle like this, you need it for whatever purpose. As a chief officer, what can you decide? Okay, I will measure the breadth of the ship, this forecastle at few select points, and then I will put it through the integration process through the Simpson's rule, and I will get the area of the forecastle. Now, sorry, not Simpson's multiplier, sorry, this is common interval. The common interval is first that I'll cover, represented by small h. In Simpson's rules, it's important that when I decide to take certain ordinates, measure it at few stations, these are the ordinates I have picked up, which I'll put through the Simpson's process to get the area. Now, what is important in Simpson's rule is that these ordinates must be equispaced. The ordinates has it is that is how it has been derived. Ordinates must be equispaced. That means whatever is the spacing between these two ordinates here, h, same should be the spacing between these two, same should be the spacing here, same should be the spacing here, and same should be the spacing here. If you do not take them at equal intervals or equispaced intervals, Simpson's rules cannot be applied. Simpson's rules cannot be applied. So it is imperative that the ordinates in Simpson's rules are taken at equispaced intervals, and this interval, whatever its value is called as common interval. Why? Because it has the same value for it is equispaced, so it is common factor to all the ordinates. So it's called common interval, represented by small h. Have you understood the meaning of common interval, guys? Yes or no?
Yes, sir.
So now, for example, if so, we have done the ordinate. Now we are talking of common interval h. In this thing, if let us say the length of the forecastle, if it is 30 meters, for example, and the chief officer feels that he'll take only three ordinates. So one he'll take here, one he'll measure this, and the third one he'll have to measure the midway. Why? Because the spacing has to be same. So in this case, the value of h will be, there are two common intervals, 1 and 2. So the value of the common interval will be 30 by 2 equal to 15 meters. Am I right, beta? Yes or no? Correct? Right, guys? Understood, beta? What is
Yes, sir.
common interval?
Yes,
Now, another chief
yes, sir.
officer may feel, no, 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 I'll not take 3, I want to take 5. Now, how many intervals are there? 1, 2, 3, and 4. So in the blue one, the value of h will be 30 by 4, that is 7.5 meters. Have you understood? So more the number of ordinates for the same situation, lesser will be the common interval. Lesser the ordinates, more will be the common interval. And now in Simpson's rules, if you want to, we said it is gives you a good approximation. So if you want to improve the accuracy, you should reduce the common interval to as low as possible. Lesser the common interval, more accurate will be the results. Higher the common interval, lesser accurate would be the result. So same for Castle. One chief officer does with 3 ordinates in the red one, another does with 5 ordinates in the blue one. Obviously, the result of the one who does with 5 ordinates will be better than the one who does with 3 ordinates. Is that clear, beta? So don't say why should I take 5. You, if you want to improve the accuracy, you will have to take more ordinates. Is that clear, beta?
Yes, sir.
Clear, class?
Yes, sir.
So we have learned 2 terms. One is the ordinate and second is the common interval. Third is Simpson's multiplier. Now, what is Simpson's multiplier? Firstly, word Simpson's here is indicates that it has come out of the derivation of the Simpson's rule. Multiplier means this number has to be multiplied with something. So these are fixed numbers. These are constant numbers. Where do they come from? They come from the derivation of the respective Simpson's rules. What do we do with these numbers? These numbers are multiplied with the ordinates. And since they are multiplied with the ordinates, they are called as multipliers. So just to cut it short, what are Simpson's multipliers? Simpson's multipliers are fixed numbers whose value depends on the rule being used. So there will be different set of multipliers for rule 1. There will be a different set of multipliers for rule 2. There will be a different set of multipliers for rule 3. So these are fixed numbers based on the rule being used. And these numbers are allocated to the ordinates. And since they are multiplied with the ordinate, they are called as Simpson's multipliers. Is the concept of Simpson's multipliers clear, beta? Is that clear, beta? Simpson's
Yes, sir.
multipliers are fixed numbers. Value depends on which rule is being used. They are allocated to the ordinates, multiplied with the ordinates, and hence called multipliers. And since came out of the derivation of Simpson's rules, they got the name of Simpson's multipliers. Is that clear, beta? Clear? Clear, class?
Yes,
Bolo
sir.
bhai.
Yes, sir.
Yes, sir.
In every question, how many Simpson's multipliers will be there? In every question, the total number of multipliers has to match the total number of ordinates. If you have 3 ordinates, you will have 3 multipliers. If you have 5 ordinates, you will have 5 multipliers. If you have 20 ordinates, you will have 20 multipliers. Okay, so each ordinate will be assigned a multiplier and will be multiplied subsequently with the multiplier. What will be their values for rule 1, rule 2, rule 3? We'll discuss in a while, but Simpson's multipliers are fixed numbers which are rule based. Their origin is from the derivation, and these are the numbers with which the ordinate shall be multiplied. Clear, beta? Clear, guys?
Yes, sir.
Then, next term is Simpson's coefficient. This is one fixed value E per rule. This is one fixed value per rule. Again, its value comes out of derivation. So Simpson's coefficient is a value, is a number, it's a fraction actually, which comes out of the derivation. And every time you use a rule 1, you will have its Simpson's coefficient you'll use. When you use rule 2, you will use the Simpson's coefficient for rule 2. When you will use rule 3, you will use the Simpson's coefficient for rule 3. So every time you use rule 3, the value of the Simpson's coefficient will not change. It will remain the same what is applicable to rule 3. Okay. What are their values? We'll learn them in a while. One rule at a time as we'll learn these values which are rule specific. Okay. Then after we have done this, how are we going to get the result? That is the issue. Okay. So see, we will make a table something like this. First, we will write the ordinates. Okay. Then we'll assign the Simpson's multipliers. Then don't number them. This numbering I am doing only two. Since the multipliers are to be multiplied by the ordinate, we'll multiply column 1 and 2 and we'll call it as product of area or product of volume, depending on what the ordinate is. If the ordinate is length, it will be product of area. Product of area does not mean its area. It's product. Why? Because you're obtaining it by multiplying 1 and 2. It's a product of two columns. That is why it's product. Why of area? Because this will eventually lead you to area. If the result is going to lead you to volume, it will be called as POV, product of volume. So the column 3 will be 1 into 2. It's called product of because it's a product of two columns. Area volume will depend upon what the ordinate is. If the ordinate is a line, it will be POA. If the ordinate is area, it will be POV. Am I clear about the third column, guys?
Yes, sir. So can we directly write product function here? Product function.
It is always good to write like this because it will always keep reminding you what you are calculating. Otherwise, you'll also forget after some time what were you calculating, right? Right.
Yes, sir.
Some if you just
Yes.
see, if you say, can I remove my first name and only start using my surname, then yes, you can use. People call you by surname in a gathering and you automatically respond to it. But in the same family, if you have 20 people with the same surname, then the surname will not be sufficient, right, beta? Correct?
Correct, sir. Correct.
So you can use you can write product, but what I'm saying is how much time it takes to keep because you have to keep reminding yourself what are you going to get. Am I right? Correct. So I would suggest POA or POV. Rest it's okay as long as the outcome comes is there. Guys,
Yes, sir.
when we get this third column, values, we'll add them all. And that will be called as SOP. S is sum of products. I'm sure you know if this column had products, then it is sum of all the products. And I personally, I prefer to write here in subscript A if it is sum of product of area, or V if it is sum of product of volume. If you don't write, it's okay, but if you write, it's always good. It will keep you always connected with the question. Okay. Once you get SOP, then the last step gives you the result. What will be the result? It will be, until now what we have learned is it will be area or volume depending on what was the ordinate, or I would prefer to call it as the result. The result will be equal to Simpson's coefficient, this one, multiplied by common interval h, multiplied by SOP that you got here, and you will get your output. You will get your result by multiplying the coefficient into common interval into sum of product. If you were dealing with SOP area, you will get area. If you're dealing with SOP volume, you'll get volume. So output will depend upon what the input was. This is the process flow for the Simpson's rules. Understood, beta? Yes or no?
Yes, sir.
Guys, if you have any questions, let me know. I know after one or two questions, it will become mechanical. But if we have an overview, that will always be helpful. Okay. Now I'll take you through a simple question. Now, you see, as I told you in the beginning, if you remember, that the basis of derivation of all the three rules is different. And accordingly, because the basis of all the three rules is different, all cannot be applied in every situation. When I mean situation, I mean number of ordinates. So based on the starting point of the derivation, there is a certain condition for applicability criteria. And now I will talk about rule 1 only for some time. Then we'll go do some questions about rule 1. Settle down with the process. Then we'll just learn the changes to be made for rule 2 because the process will remain same. Rule 3 we'll put on hold for a while because that's slightly somewhere it is common to the two, somewhere it is different. So that will be dealt with later on once we are all done with rule 1 and 2. There is one okay. There is one mic which is echoing. Better. Applicability criteria. Okay. So every rule cannot be applied in every scenario. Please remember that. So now we are talking of rule 1. When can rule 1 be applied? Rule 1 can be applied when you have minimum 3 ordinates. Okay. Minimum 3. What happens after that? We'll add to that in a way. Let's take an example of the voxel and calculate. Let us say this is the voxel. The ordinate here is 0. Let's say it is 20. And midway between the two, if you measure, let's say it is 12 or 13, whatever it is. These are the ordinates. 0, 12, 20 are the ordinates. And let us say the length of the voxel is 30 meters. So h will be 15 meters, which you all know now. Now, since there are 3 ordinates, rule 1 is definitely applicable because we have just written that rule 1 to be applicable, minimum ordinates required is 3. Now, if 3 ordinates are there, then there have to be 3 multipliers. Okay. So Simpson's multipliers for rule 1 for 3 ordinates is 1, 4, 1. Every time you use rule 1 and you have only 3 ordinates, every time the multipliers will remain 1, 4, 1. Now this sequence is very important. Don't make it 1, 1, 4. Don't make it 4, 1, 1. It will mess it up otherwise. So please respect the sequence order. It's 1, 4, 1. Now and what is the coefficient for rule 1? Coefficient for rule 1 is 1 by 3. So every time rule 1 is used, coefficient will be 1 by 3 only. And every time rule 1 is used and you have 3 ordinates, multipliers will be 1, 4, 1. Now guys, when it comes to calculating area now, we'll first put ordinates. Now when it comes to writing the ordinates, it is up to you whether you want to start with 20 or you want to start with 0. But you start from one end, and whichever end you start with, do not jumble up the order thereafter. After that, the order cannot be messed up. You have to strictly stick to the order of the ordinates. You have the liberty to start from left or the right, top or the bottom as the case be. But once you start, you cannot jumble up or mess up the order. So somebody may say, sir, I'll write 20, 12, 0. Perfectly fine. Another person may say, no, sir, I want to write 0, 12, 20. He is also right. But you cannot write 20, 0, 12 or 0, 20, 12. You cannot change the order. Am I clear, beta? Clear?
Yes, sir.
Then you will write the Simpson's multipliers. Since there are three ordinates, there will be three Simpson's multiplier and their order has to be respected. So obviously it will be 1, 4, 1. 1, 4, 1. You will not do both ways, you will do only one way. When you multiply them, you will get product of area. 20 into 1, 20, 12 into 4, 48, 0 into 1, 0. SOP area is 68. You see why the order did not matter, because in between the multiplier in the center was 4, on either side was 1. So you'll get the same product of area here also, 0, 48, 20. Only thing is 20 has gone down, 0 has come up. That's all that has happened. SOP area again becomes 68. So either you do this way or this way, they are going to get you the same SOP. Now, the area of this forecastle will be equal to coefficient 1 by 3 for rule 1. Common interval 15 meters. SOP area 68. 340 square meters will be the area of the forecastle by rule 1 3 ordinates. Rule 1 3 ordinates will give you 340 square meters. Now units will depend on the unit of the ordinate. If ordinate is in centimeters, area will be centimeter square. If ordinate is in meters, area will be meter square. If ordinate was feet, it will be feet square. So area unit or the output unit will depend on the unit of the input. Is the process clear? Am I clear about the unit issue also, beta? Yes or no?
Yes, sir.
Guys, any questions? Okay. Somebody says, no, I don't want to do with 3, I want to do with 5. Let me do it with 5. So 12, 20, let me remember that, and answer 340. Okay. Let me clear the board, and the same thing let's do with 5 ordinates. Same 30 meters length, and the mate decides to take 5 ordinates. So H will be 30 by 4, 7.5 meters. This was 20, this was 12, this was 0. He takes some more out here. Let's say this is 7, and let's say 32, 16. Let's say this is 18. Let us say these are the ordinates the mate has got now. It's the same voxel which was there, which we just calculated. Now you see, guys, in this case, this area can be considered to be divided into two parts, A1 and A2. Correct, beta? Yes or no? Correct, class?
Yes, sir.
Now, A1 comprises of 3 ordinates. A1, now I will, A1 comprises of, now I'll not use the values, I'll number the ordinates. Let's say this is Y1, let's use a generic value, Y1, Y2, Y3, Y4, and Y5. Okay. Now, both the areas A1 and A2 can be separately calculated using rule 1 that we have learned until now. Can area 1 be calculated by 3 ordinates? Yes or no? Am I right, guys?
Yes, sir.
Yes, sir. Possible.
And so is area 2. So let's call this as area 2, area 1, doesn't matter whichever. Now the table for A1 will be then ordinates let me start writing from y1, y1, y2, y3. Simpson's multiplier 1, 4, 1. Product of area 1 will be y1 into 1. I'm underlining the Simpson's multipliers, guys. y2 into 4, y3 into 1. And this will give me SOP A1. It will be y1 into 1 plus y2 into 4 plus y3 into 1. Does everybody agree with the calculation of A1? Yes or no?
Yes, sir.
And now, what will be area 1 equal to? This common interval is h, so it is coefficient 1 by 3, common interval h into SOP A1, y1 into 1 plus y2 into 4 plus y3 into 1. And this will give me area A1. Do you agree with me, guys? This gives me area 1, yes or no?
Yes, sir.
Yes.
Exactly the same way. Area 2 comprises of three ordinates, y3, y4, and y5. I can calculate A2 also. Ordinates y2, y3, y4, y5. Simpson's multiplier for three ordinates will be 1, 4, 1. Product of area 2 will be equal to y3 into 1, y4 into 4, y5 into 1. And SOP A2 will be equal to y3 into 1 plus y4 into 4 plus y5 into 1. And now if I want to calculate area 2, since I have used rule 1, coefficient will be 1 by 3, common interval is h, SOP A2 is y3 into 1 plus y4 into 4 plus y3, y5 into 1. But I don't want area 1 or area 2. What do I want? I want the total area. And you can see, look at the diagram. Total area A will be equal to A1 plus A2. And when I add A1 and A2, this is common to both. So this will be outside the bracket. And everything inside the bracket gets added up. So it will be y1 into 1 plus y2 into 4 plus y3 into 1 plus y3 into 1 becomes y3 into 2 plus y4 into 4 plus y5 into 1. Does everybody agree with me? Yes or no, beta?
Sir, can we solve this question directly by 14241?
अबे
So,
रुक जाना यार. Guys, can we do it this way? Yes or no?
yes, sir.
Yes.
Okay.
Yes, sir.
There is
Yes.
nothing wrong. It's perfectly in order. Only thing is, it will engage more time. Yeah. Tell me. Tell me. Okay. We can calculate it like this. There's nothing wrong in it. Only thing is it ends up taking more time because you've made two tables, you're dealing with two areas, putting them together, and it becomes a lengthier, effort intensive process. But if you do like this, answer you're getting correct, no problems. Now,
So one doubt, sir.
yeah,
Sir, in this area A1 plus A2, that Y3 into 1, we have to do it two times or just one time only we have to
you
add
see,
it?
tell me, we have calculated and added. You tell me, when you add, what are you getting? How many times are you getting y3? You tell me. It's a
Sir,
simple
two times.
mathematical. So that is why this y3 into 2 has come here, no, bete?
Okay, sir.
Yes or no?
Yes, sir.
Am
Yes,
I
sir.
right?
Yes, sir.
Right? It's y3 into 1 plus y3 into 1 becomes y3 into 2. Yes or no?
Yes, sir.
Rest everything is as it is, right?
Yes, sir.
Yes?
Same, sir.
Yeah. Now, guys, if you do like this, it is effort intensive, it's lengthier, time consuming. That's all. Technically, there's nothing wrong. Okay. Now, if you look at it, what have I been underlining from beginning? I have been underlining the multipliers. What do you see has happened here in y3? Why did y3 become 2? Let's go back to the diagram. Let me assign the multipliers on the diagram. We have 1, 1, 4, 1 from here. You see y3 was given 1, y4 was given 4, y5 was given 1. And then y1 was given 1, so 1, 4, 1. So what has happened if you look at this diagram? The dividing ordinate y3 got one multiplier from for area 2 and it got one multiplier for area 1, and therefore effectively if I want to do it in one go rather than making two different tables, I can take the multipliers as 1, 4, 1 plus 1, 2, 4 and 1. So either I have a choice, either I make two tables or I make them in one table by changing my ordinates, multipliers. So look at what has been underlined. It's 1, 4, 2, 4, 1. So instead of saying 1, 4, 1 for 3, it is 1, 4, 1 for 3. But I can, if I have 5 ordinates, and instead of making two tables, I can make it 1, 4, 2, 4, 1. And I will be able to do it in one table. Yes or no, beta? Am I right?
Yes, sir. Yes, sir.
Okay. So we can, instead of wasting time and effort, we can do it in one go. If we have 5 ordinates, our multipliers will become 1, 4, 2, 4, 1, and rule 1 is applicable. So coefficient will remain 1 by 3. Only thing is now multipliers have become 1, 4, 2, 4, 1 because the minimum number of ordinates required for rule 1 was 3. We use the same concept, split it into two areas, and we arrived at this inference. Okay. So when you'll derive rule 1, you'll derive it only for 3 ordinates, but you can now see you have extended it to 5. Exactly the same way you can add another 2, another 2, another 2. And every time you'll find rule 1 becomes applicable because you can divide the area into sections of 3 each, and you will be able to do it section wise, add them, or you can do it collectively. So basically the applicability criteria for rule 1 is, so from this what do we infer? We infer that the applicability criteria for rule 1 is minimum ordinates you should have 3, and if number of ordinates is minimum, then Simpson's multiplier will be 1, 4, 1. If the number of ordinates is more, then you'll count the total number of ordinates. And if the number of ordinates is odd, you can still use rule 1. Then what will happen? Your how many multipliers will you have? It depends on number of ordinates. If you have 7 ordinates, you'll have 7 multipliers. If you have 13 ordinates, you'll have 13 multipliers. So how do you assign the multipliers? They will follow the same pattern. What do? This, you start with 1. This 1, 4 goes, 4, 1 goes in the end. And in between, from 3 to 5, how many are you adding? 2. So you keep repeating 4, 2, 4, 2 as many times as required, and with 4, 1 till the number of multipliers equals to number of ordinates. So please repeat to yourself a few times. For rule 1, applicability criteria first. Repeat to yourself. For rule 1, applicability criteria is minimum number of ordinates 3, in which case multiplier is 1, 4, 1. In K, for more than 3, rule 1 can be deployed if the total number of ordinates is odd. So rule 1 can be applied if number of ordinates is more than 3, also provided the total count is odd, it is not even. And based on the number of ordinates, then your multipliers will be, repeat to yourself silently a few times, 1, 4, 2, 4, 2, 4, 2, 4, 2. Keep repeating it as many times as you need, but end with 4, 1. So 1, 4, 2, 4, 1, 1, 4, 2, 4, 2, 4, 1, 1, 4, 2, 4, 2, 4, 2, 4, 1. You will keep repeating 4, 2 as many times as required till and end with 4, 1, so that total number of multipliers equals to number of ordinates. Is that clear, beta? Is that clear?
Yes.
Clear to everybody, guys? When will rule 1 be applicable? And coefficient for rule 1, whether you have 3 ordinates, 5 ordinates, 7 ordinates, 13 ordinates, 21 ordinates, coefficient will always be 1 by 3. As long as you are using rule 1, coefficient will remain 1 by 3. Guys, any questions on applicability, assignment of Simpson's multipliers, and coefficient for rule 1? Please let me know. Is it clear? Can you silently repeat to yourself 1, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 1? 1, 4, 2, 4, 2, 4, 2, 4, 2, 4, 2, 4, 1. It will end with 4, 1. Is that clear, beta? Clear, class?
Yes.
Now, before we go to the question, a last issue which needs to be tackled, and then we'll be good to take the question from the exercise. We have dealt with the ordinate being area, or instead of area line, or instead of line area, it would have been same. Let's go back to the same forecastle. Suppose the chief officer wants to know what is the distance of the geometric center of this forecastle besides area from this axis. Guys, when you have to find out the kg of the ship, that means distance of center of gravity of the ship from keel, what do? You find the moments about keel and divide by the displacement of the ship. Yes or no, beta? You find the vertical moment and divide by displacement. Am I right? Correct? Correct, guys?
Yes, sir.
When you have to find the LCG of the ship, what do? You find the longitudinal moment divided by displacement. So you find the moment about the axis from which the distance of the centroid is required. So here, if I need the centroid of this area from YY, what will I do? What will I need? I will need the moment of this full area about YY. Am I right, beta? Like to get kg, you need the moment about keel, and then you divide by the weight. So here, since I want the distance of the geometric center from YY, I will need the moment of this area about YY. Let us say the mate has taken 3 ordinates, Y0, Y1, Y2, and Y3. This is Y3. Okay, area you can calculate, that is not an issue, we have just discussed. So the area would be equal to, let me just put it in short, area will be equal to, for area calculations, let's go area calculations, let's say Y1, Y2, Y3. Simpson's multiplier, 1, 4, 1. Product of area, Y1 into 1, Y2 into 4, y3 into 1. We get SOP area and we close out the question. Okay. Now guys, to get the moment, remember the ordinates input. If I want the moment of area, what should be my input, beta? Do you remember that slide? If I want the moment of the area, what should be my input? Ordinate?
Moment of line.
Moment of the
length,
line. Okay, very good. Tell me, look at this. And what is the lever? Lever is the perpendicular distance of, complete the statement. Lever is the perpendicular distance of the centroid of the area, volume, or the ordinate from the reference axis. Am I right, guys? Yes or no? Okay.
Yes, sir.
So now tell me, what will be the moment of y1 about yy? Tell me. Moment of y1. What will be the moment of moment about yy? Capital YY of y1. What will be the moment, guys? Tell me of y1. Look at the diagram.
Lever from Y1. Y.
What is the lever? Common interval is h.
Y into y1.
So
Now tell
2h
me.
into
H into 2.
2H.
That will be lever. 2h will be lever. What will be the moment of y1? Tell me the moment.
Y1 into 1 into 2H.
Y1 into 2h. Correct? Correct, beta? Am I right?
Yeah.
What
Yes,
will be
Yes, sir.
what will be the moment of y2 about yy? Look at the diagram and tell me.
Y2 into H.
y2 into h.
Y2 into 1h. Okay, let me write 1h. H, correct. What will be the moment of y3 about yy?
0.
Y3 into
Y3
0H.
into
y3 sir.
0h. Correct.
0H.
Guys, now these are the moments. If I integrate the moments of the ordinates, what will I get? First answer that question. If I integrate the ordinates of these moments, what will I get the result? Moment
Moment
of
of
area.
sir.
Correct? So guys, if now you see here, now my ordinate for Simpson's rule become these: y1 into 2h, y2 into 1h, y3 into 0h. What am I doing? I'm integrating them using Simpson's rule now again. And since there are three ordinates, now they become the ordinates. The moment of the ordinates have become the ordinates now. And now the Simpson's multiplier will be 1, 4, 1. Product, now when I multiply these two, they will not give me area or volume. They will take me towards the moment of full area. So this will be called as product of moment, right? And this will be y1 into 2h into 1. I am underlining the lever. Moment multiplier, sorry. Y2 into 1h into 4. Y3 into 0h into 1. Now I can find SOP moment and I can get the moment by coefficient into common interval into SOP moment. That we can complete. Better mute yourself. Then you mute yourself. Then you mute yourself, please. Mute yourself, please. अरे mute कर ले भाई. हाँ, thanks. Now, guys, yes, we can calculate area in a separate table. We can calculate the moment in a separate table and use them. But again, it's going to be waste of effort and time. Why? Because if you compare the product of area with product of moment, what is the difference between them? Compare them and see. It is y1 into 1. It is y1 into 1 and additionally multiplied by lever. Y2, it is y2 into 4 It's y2 into 4 additionally multiplied by liver. Y3 into 1 additionally multiplied by liver. That means if I multiply the product of area by liver, that will give me product of moment. Yes or no, beta? So why make two tables? Correct?
Yes, sir.
Understood? So instead of making two separate tables, we can extend this table further. Why? Because if I put here liver of the ordinate about y, look at the diagram. What is the liver of ordinate y1 from y? It's 2h. What is the liver of y2? 1h. What is the liver of y3? 0h. And when I multiply these two, I get the product of moment about y, and I'll get the same thing which I got in the blue when I worked separately. I'm going to get the same thing. So guys, what will happen? We will expand the same table rather than making one table for area or volume and another table for moment. We will not make two separate tables for rule 1 and 2. We will just make a simple same table, and we will add two more columns to it and add the liver and product of moment instead. So we will not make a separate table like this. We will just proceed extending this table. Is that clear, beta? Clear, class?
Yes, sir.
Okay. Guys, now we'll be doing 20 odd questions in the class. So don't try to unnecessarily bother yourself beyond a point. You will all be comfortable in another 2-3 days when the exercise gets over, and we'll all be comfortable with that. I'll take you to the first question that we'll discuss. I've shared the questions with you. First, I'll take the second question of the exercise because for the first question, rule 1 is not applicable. So this is the structure of the table we'll be following, beta. This is the structure of the table. We'll have the ordinates, we'll have Simpson's multipliers, we'll have either product of area or product of volume, we'll have liver and product of moment. We'll sum it up, This will be product SOP area or SOP volume, and this will be SOP moment. And we'll finally use this formula to get the answer. Is that clear, beta?
Yes, sir.
Let's look, guys, this is one of the questions from the exercise that I've shared. Now, what is important in Simpson's rules? Now pay attention, beta. In Simpson's rules, it's very important that the question is read carefully. It is important for all topics, and it's very important out here. Because if you read the question wrongly, you will get on a wrong track and you'll mess it up. Simpson's rules by itself is very simple. It's like a drill day's work. You'll get in no time over it and you'll be comfortable. You are likely to mess it up, primarily because of your carelessness. Okay. Now, the breadth of a transverse watertight bulkhead at 2 meters interval from bottom. So from where are they given? You have to make a note of it in the question. These are given from bottom, not from top in this case. Guys, so what are the ordinates? Ordinates are the breadths of a transverse watertight bulkhead. What is 2 meters in this case, guys? Can you tell me what is 2 meters?
H, sir.
H. Common interval. Very good. Please count on the screen only how many total ordinates are there.
5.
5.
5, sir, 5.
For 5, if 5 is rule 1 applicable, these are the questions I'm asking myself. Yes.
Yes, sir.
Rule
Yes.
1 is applicable if 5 is odd. Next thing, once you have read the question, next important thing is making a suitable diagram. I'm not saying whether you use scale or do what you do. Make a neat hand-drawn diagram which looks relevant to the question. And always tell yourself the diagram is not for the examiner. The diagram is going to help you in solving the question. Okay, beta? Because you will be using the diagram. If you don't make an appropriate diagram, you'll mess it up. I'll make a diagram for initial 1 or 2 questions, and then I'll give you the charge. I'll start following you. and you will take the lead. For example, in this case, the diagram I'll make is like this. This is the transverse watertight bulkhead. They have given us 5 ordinates at equispaced intervals. So these are the 5 places where the breadths are measured. Ordinates given are from bottom to top. So the lowest one is 2 meters, then 5.8, then 8.4, 10.2, and 11.4. Do you agree with the question, this diagram, guys? Yes or no?
Yes, sir.
Guys, if you have any problem, because if you have a problem with the diagram, you'll have problem with the question. Please trust me on that. So if you have any problem with the diagram, let me know. You have to make the diagram carefully. There are 5 ordinates from bottom to top, and we have marked them as. So we are trying to transfer the relevant information to the diagram. H is 2 meters. Okay. We have to calculate this area, and we said it will be by rule 1. So that will give us answer to part 1. Read the part 2. Read the part 2, guys. Part 2 is talking of what? Distance of the GC of the bulkhead from bulkhead top. If I tell you to find the kg of the ship, you can't get the kg till you get the vertical moments. If I tell you to calculate the LCG of the ship, you can't calculate unless you calculate the longitudinal moment. So here he is asking you to calculate the distance of the geometric center of the bulkhead from the bulkhead top. So if he's asking it from the bulkhead top, so what should I be aiming at? I should be aiming at calculating my moments about the bulkhead top. Am I right, beta? Then only the distance will come straight from bulkhead top. Correct?
Correct, sir.
Yeah. So we have to choose an axis. Somebody will say, no, I'll choose the bottom as the axis. You can choose it, but then you'll get the distance of the GC from the bottom. Then you'll have to add, subtract in the end. You will unnecessarily be increasing your thing and chances of missing out on the final step. So first effort we should make, now I'm making a very important statement. Try and see, can you use the axis about which results are required? There may be some situations in which you have to avoid that axis. We'll see that when it comes. So we'll see in a given question, can I directly use the axis for moments from which the results are required? In this case, my question is can I use the bulkhead top as the axis? Well, in this case, there is absolutely no problem because it is one of the extremity. So we take bulkhead top as the reference axis. So why have we chosen bulkhead top as the axis is clear to everybody? Yes or no, beta? Correct? Correct, class?
Yes, sir.
Yes, sir. Yes, sir.
Okay, so choice of axis should be smart, which reduces your workload. It's a game of moments. Somebody can take bottom also. You will still get the answers by adding, subtracting. But why unnecessarily keep complicating things for yourself? So it's a question of keeping things simple. Now we go to the table. What will be the first column? First column will be the ordinates. Okay, guys. Now, as I said, you can write these ordinates from top to bottom or bottom to top. Technically, it doesn't matter. Technically, it doesn't matter. But what will be more convenient to you? Pay attention to this. It's only a recommendation. That write the ordinates starting from the one closest to the axis. Write with the ordinate closest to the axis. Why? Then writing levers will become easier for you. Writing levers will become easier for you. So if you want to follow my recommendation, then which should be the first ordinate written, guys? 2 or 11.4?
11.4.
11.4.
So I would prefer to write from
11.4.
11.4. Technically, somebody from writes from 2, I am not against it, but that is not going to be making things comfortable to you. If you want it to be good and comfortable for you, start thinking of writing the ordinates, the one closest to the reference axis. So we'll write these ordinates, then we'll have Simpson's multipliers, we'll have product of area. Since we want the distance of the GC from top and we have already taken the reference axis XX, and you see now how I'll write the liver. Where do I take the livers from? See the column header, liver in subscript XX. That means I'll take the livers about XX. If livers are taken about XX, it will give me product of moment about which axis? It will give me about XX. Are the column headers clear, beta? Yes or no? Are they all clear? Tell me now. All clear, beta? Why
Yes, sir.
they've been written like this? Now I'll write the ordinates starting with 11.4, 10.2, 8.4, 5.8, 2 meters. Obviously, once you start, you can't jumble up the order. Guys, in your mind, please think of the multipliers. These are 5 ordinates. 1, 4, 2, 4, 2 as many times you need, end with 4, 1. So it will be 1, 4, 2,
4 1.
4, 1.
4
Correct?
1.
Right? Then we will multiply the ordinate with the respective multiplier and we'll get product of area. But before you pick up the calculator, write the liver. Now guys, in Simpson's rules, whether I want to write a liver as multiple of h or do I want to use the whole number, it's your choice. We will be driven by our convenience. It is not necessary that you write 0h, 1h, 2h. It's nor is it necessary you write 0, 2, 4, 6, 8. No. You can write whatever gives you comfort. What is our objective? Our objective is my calculation, my process should be simplified. So whatever we do in the liver, how we want to use livers, it should be the way they simplify things for you. If you don't want to use a simplified route and go on a complicated one, that's okay, that's fair. You're only increasing your workload. So there is nothing, no hard and fast. Don't tell me, sir, somewhere you're taking liver as 0h, 1h, 2h, 4h, 3h, somewhere you're taking pure numbers. I will be driven by my convenience, my comfort. As long as I'm taking the livers correctly, in which format am I taking does not matter. Is that clear, beta? So don't ask me questions. Sir, you have taken as multiple of h. I have taken 0, 2, 4, 6, 8. Am I right? Yes, of course you're right. Is that clear, beta? Clear, guys?
Yes, sir.
Okay. So then write the livers. For livers will come from the diagram. When you are filling up the liver column, your eye should be going to the diagram. 11.4. What is the liver from XX?
0.
Write 0h. Otherwise, 0 is correct. Absolutely correct. 10.2. If I am taking multiple of h, it will be 1h. If you are not taking
1h.
multiple of h, it will be 2 meters. Correct? Correct, beta? And these will be the livers if I'm taking as multiple of h. Am I right, beta? If you are not taking multiple of h, then livers will be 0, 2, 4, 6, and 8. Then there will be no h in this, right, beta? Am I right?
Yes, sir.
Correct? Now I pick up the calculator. I multiply on the calculator this one and this one. Put down the value here. Don't delete the value. Multiply by the liver and fill it up here. Then do the second line, third line, fourth line. Complete them line wise. And we get these values. Please confirm if you are okay with the table that I have filled up. Clear, better? So if you have H in the liver, it will be there in product of moment also. It should not happen that you forget carrying over H there. When you're multiplying, H has to be there. Now, which columns will you add? You'll add the product columns. There are two product columns, POA and POM. One will be called as SOP area. Other will be called as SOP moment about which axis? About XX. And this comes, those who have used 0, 2, 4, 6, 8 will get 304 and will not have H in the SOP moment. Those who are using H will get 152H. Am I clear up to this point, guys?
Yes, sir.
Now we are good to calculate area and answer part A. Area will be equal to coefficient multiplied by common interval multiplied by SOP area, which is 94.2. Coefficient will be 1 by 3 for rule 1. And when we put these values, we get area as 62.8 square meters. Yes or no, beta?
Yes, sir.
Yes, sir. Yeah.
Okay. Why meter square? Because these are in meters. Then we want the distance of the GC from XX. It will come because we have taken livers about it. I call it as DXX. Guys, do you agree with this? What has come up on the screen now? DXX will be moment of the area about XX divided by area. Yes or no? Am I right?
Yes.
For kg, you take the moment about keel divided by the weight. Yes or no? For LCG, you take the moment about after perpendicular and divide by the weight. Yes or no, beta?
Yes, sir.
So it will be moment of the area about XX divided by area. How do I get the moment? We already have product of moment about XX. We put it through the last step of Simpson's rules. What is the last step? Result is equal to coefficient into common interval into SOP moment. You see here. Do you agree with this? 1 by 3 the coefficient, 2 the common interval, SOP moment 152 into 2. 2 is for this H divided by area. The same thing has come here. 1 by 3, 1 by 3, 2 and 2 get cancelled, and you are left with 3.227 meters. Is that clear, beta? That means the distance of the GC of the area from bulkhead top is 3.227 meters. Any questions?
No.
The third part of the question has nothing to do with the Simpson's rules. It is from pressure thrust of Captain Subramaniam, chapter 2 in pre-C that you did. He says, find the thrust on the bulkhead when it is pressed with sea water to a head of 6 meters. Guys, when we say something is pressed to a head, means it is above the top of the tank. That means the water level is in the sounding pipes and air pipes up to 6 meters above the top of the tank. So first I'll mark this geometric center on the bulkhead diagram. It is 3.227 meters from the bulkhead top. You see on the diagram, here comes the GC, and this distance is 3.227 meters. Am I right, beta? Yes or no?
Yes, sir.
Then the tank has a head of 6 meters. You see, it has a head of 6 meters. This is the liquid level, and this is 6 meters. Do you agree? Yes or no?
Yes.
Guys, how do we find thrust from pre-C? Thrust is equal to pressure at GC into the area. Area you already have 62.8 square meters immersed area. Pressure at GC is equal to what? Depth of the GC below the liquid level multiplied by density of the water. Yes or no, beta? Density of the liquid, correct? Correct, guys?
Yes, sir.
So what is the depth of the GC below the liquid level? Look at the diagram. What is DLL?
9.227.
9.227. So now we have the thrust equal to pressure at the GC into area. Area, you already know. What is the pressure at the GC? Pressure at the GC is Distance of the GC from liquid level multiplied by density of the liquid. This is the pressure multiplied by area. DLL in the diagram is 9.227. Density of the liquid is seawater 1.025. Area is 62.8. And we get a thrust of 593.942 tons. Am I right, guys? Am I right?
Yes, sir.
I'll clear the screen and show it to you and leave the screen on. You can take a 5 minutes break, also review the screen and let me know if you have any doubts on this question. After the break, you can first clarify that. We'll take one or two more questions on rule 1 and then move on to rule 2. The full question is on display. I've explained to you. And now the time now is 1916. Let's start at 1922 beta. Let's not drag it to 25 also. Let's make it 22. 1922 we start. So take a break. So the slide is on for people to review and come with their doubts. Chalo. Take a 5 minutes break.
Hello.
Okay, class. Good to start, guys. Good to start.
Yes, sir.
Okay.
Sir,
Any?
when you were
Uh,
explaining this axis XX, I had a network issue, so I could not clear it properly, sir. Could you please repeat the axis?
I said you have to choose a suitable axis
Huh?
because you were interested in conversation that time. You were third party discussion you were involved in. That was you. It was not your issue. Okay. So
Yes, sir.
let's not fool ourselves. So if you have parallel engagements, then you'll have problems, no?
Uh,
Sitting here, I know, yeah, what is happening at your end. So let's not fool ourselves and suddenly become so innocent that you had an internet issue. But after axis XX, we discussed this question for a lot of time. No, why you didn't clarify then? Because you have joined now, is it? Again.
no, sir, no, sir. I was there in the class. I thought I'll
So,
ask at the last.
no, but then you should have asked, no, in the last. When I was asking, is it clear? Is it clear? Then everybody said yes.
सर
Yeah, tell me.
सर एक डाउट है सर, ये अभी जो हमने प्रेशर थ्रस्ट कैलकुलेट किया है सर, इसमें हमने ज्योमेट्रिक सेंटर 3.227 जो आ रहा था हमारा, इस पे लिया है। क्वेश्चन में इन्होंने बोला सर थ्रस्ट ऑन बल्कहेड व्हेन इट इज प्रेस्ड विद सी ऑर्डर टू हेड ऑफ 6 मीटर। ये 6
हाँ,
मीटर से ऊपर समझ में आ गया। हमने ये जीसी यहाँ से क्यों किया? ये तो हम क्वेश्चन में उन्होंने दिया हुआ था कि
क्या?
टॉप से लो, ये जीसी तो हम सर डाउन से भी कैलकुलेट कर
How
सकते
do you
हैं।
answer my question? How do you calculate thrust? Tell me just that. Chapter 1 and 2 of Captain Subramaniam Stability 1. How do you calculate thrust and pressure? Tell me that.
सर वो तो उसी से करेंगे, डेप्थ से,
कितने नहीं? Tell
डेंसिटी
me,
से,
tell
लेकिन
me,
हमने यहीं से भी लेंगे सर।
one second. Tell me, how do you calculate thrust? What is the formula for thrust as per chapter 2, 1 and 2 of Captain Subramaniam?
सर वो तो यहाँ पे लिखा है सर, वो वैसे ही करेंगे,
यहाँ
लेकिन
का
मैं
नहीं, I'm asking you something you learnt at pre-C भाई. यहाँ के लिखे को छोड़ दो ना. I'm asking you what is thrust. Don't tell me you heard thrust and pressure for the first time today.
Thrust is pressure into area.
तो प्रेशर इनटू एरिया। सर मैं ये कह रहा हूँ कि हम ये इस क्वेश्चन
एक
में
मिनट यार, जो मैं पूछ रहा हूँ तो बता दो ना, व्हाट इज थ्रस्ट? तुम जो पूछ रहे हो तभी तो बात आएगा ना उसका आंसर, बिकॉज योर प्रॉब्लम लाइज देयर. What is thrust? Because you don't know what thrust is, that is the problem, and then you don't know what is the pressure. How do you calculate pressure? And in the a smart guy would have in the break pulled out the book and seen what is pressure and thrust. यहाँ पे लिखने का बात थोड़ी है. This is something which you, I said it is chapter 1 and 2 of ship stability 1. Yes or no? Tell me what is pressure and thrust, bhai. Gurmeet,
सर यस
what is thrust and pressure?
सर, जो हमारा ये प्रेशर है वो थ्रस्ट अपॉन एरिया का सर इसका फॉर्मूला होता है।
Eh? Pressure का क्या होता है? Thrust upon area. So what is thrust equal to? I'm not asking pressure equal to. What is thrust equal to?
सर वो मल्टीप्लाई कर देंगे सर, प्रेशर इनटू
Is
एरिया।
and how do you get the pressure at a point? Pressure where? For thrust, pressure at which point? Pressure at every point on the bulkhead will be different. So pressure where? At which point? See, तुम incomplete अगर जवाब
सेंटर होगा
दोगे. Center क्या? किसका center? क्या? What do you mean by center? This is the basic problem. What do you mean by center? Center of what? Pressure में you said it is the thrust में you said pressure. Pressure where? Pressure. It is something like this. You're just making a random thing. Pressure is equal to thrust is equal to pressure into area. Pressure where? Yeah. You can't take pressure anywhere and then start. Tomorrow you can't have multiply atmospheric pressure with area and say this is the thrust on the bulkhead. Pressure where? Of what? बोलो भाई गुरमीत. अरे भाई, I'm expecting your response. I have spoken enough. Waiting something from your side now. Gurmeet, are you in the class? Guys, am I
Yes, sir.
audible? तो फिर जवाब क्यों नहीं दे रहे? कितनी बार एक बार में बोलूंगा यार? I'm also a human being, no? 4 times I've called you out and you don't want to respond after that. If you're asking a question, either you remain engaged in a discussion, otherwise don't ask questions, man. You can't ask a question and go into hiding behind the wall. Five times I've asked you pressure where? You're not answering that question. Gurmeet?
सर मेरे क्वेश्चन मैं नहीं समझ पा रहा हूँ, मैं या वो कंफ्यूज हो रहा हूँ सर, मैं अभी इसलिए चुप ही हूँ.
No, you said, Arey, you just now said thrust is equal to this. So then complete that question, no? बेटा, अगर आपको ये प्रेशर थ्रस्ट में प्रॉब्लम हो रही थी तो ब्रेक को यूज करना नहीं है था गुरमीत, तुम्हें कुछ पता करने के लिए क्या थ्रस्ट होता है, क्या प्रेशर होता है? तुम तो ऐसे कर रहे हो जैसे कि तुम्हें एग्जाम देना ही नहीं. यू आर बिहेविंग लाइक दैट, यू नो. And even if I tell you, you will say, okay, yes, sir, but I can, believe me, it will not stay with you. It will not stay with you. Like Danny had his parallel engagements, you may have had your parallel engagements. So what was your question? Gurmeet, can you repeat your question?
सर मैं ये कह रहा था, ये जो डिस्टेंस पार्ट 2 में पूछा इन्होंने, डिस्टेंस ऑफ बल्कहेड जीसी फ्रॉम द बल्कहेड टॉप,
वो तो
इसमें अगर इन्होंने
3.2 वो तो 3.227 आंसर दे दिया ना भाई.
हाँ जी सर,
हाँ, फिर उसके बाद ओके.
अगर इन्होंने ये सर ये चेंज कर दिया होता कि
ऐसा है
इसको,
कर दिया मैं हाइपोथेटिकल क्वेश्चन आंसर नहीं करता. आई डोंट आंसर हाइपोथेटिकल क्वेश्चंस बेटा, प्लीज. Now, what is your doubt? Tell me the doubt on the question. You can be in your flight mode and keep thinking whatever you want to think. What is the doubt? Now tell me. Is it the first part of the question, the second part of the question, or the third part of the question? Tell me that.
सर यही था कि अगर इसको नीचे से बोल दिया होता है, कहीं और से बोल दिया तो क्या करेंगे?
जब एक्सेस ले रहे थे तो मैंने क्या लेक्चर दिया था तुम्हें? What lecture did I give? Can you repeat that, Gurmeet? When we chose XX, so that Danny also can benefit.
सर आपने ये एक्सिस इसमें जैसे टॉप से बोला था, तो हम टॉप से लेंगे सर उसको,
नहीं,
ये
एक्सेस टॉप
बताया
से
था
क्यों
सर.
ली थी? क्यों ली थी एक्सेस टॉप से?
सर क्वेश्चन में मेंशन्ड है सर.
क्या क्या कहाँ मेंशन है कि एक्सेस टॉप से लेना है? कहाँ लिखा हुआ है ये तो
सर
कहीं
द
नहीं लिखा.
डिस्टेंस,
एक्सेस
सर जो
एक्सेस हमने टॉप एक्सेस टॉप से क्यों ली थी? Why did we prefer to take access from top?
कन्वीनियंस के लिए.
मुझे एक बात बताओ, तुम्हारे सामने जो तुम्हारे कमरे की दीवार है, ठीक है, वो चाहे रेक्टेंगुलर है या कर्व्ड है, जो भी कुछ है, उसका ज्योमेट्रिक सेंटर तो एक ही पॉइंट होगा ना गुरमीत? यस और नो?
हाँ जी सर.
अगर मैं तुम्हें उसका डिस्टेंस छत से, if I give it from the roof, and tomorrow you say, no, I want from the floor, how will you get it from the floor? Tell me. If you know the distance from roof, how will you get it from the floor? Tell me. तुम्हारी दीवार का ज्योमेट्रिक सेंटर का डिस्टेंस if I give you from the roof, but you want from the floor, how will you get it from the floor, guys? Tell me, Gurmeet.
सर जो टोटल होगा उसमें से उसे माइनस कर देंगे सर, जो
तो फिर
टोटल वो
so your question was, if it was required from bottom, you can't answer from bottom then? Yes or no?
ये सर नाउ आई कैन
Or I could have changed the axis to the bottom. That's what I said. We would preferably we'll use the axis about which results are required. Did you miss out on this statement? That first we should explore the possibility of taking the axis about which the result is required. Yes or no?
यस सर
Danny, have you understood my statement now?
Yes, sir, I got it. Thank you, sir.
You should try and take the axis from which the results are required, unless there is a qualification to my statement. It's not an absolute statement. You should make an endeavor, because that will make things easier for you. You'll directly get your results from the wherever they are required. In this question, if somebody had taken the axis down below at the bottom, he would have got the total height of the bulkhead is 1, 2, 3, 4. So total height of the bulkhead is 8 meters. And if somebody had taken this axis, y, then he'll get dy through his calculation as 8 minus 3.227. That means 3, 7, 7, and 4. 4.773 meters would have been the answer if somebody works from the bottom, right? Right, beta?
Yes, sir. 4.773. Then
Yes.
8.
Yes. So what I'm saying is, you can take the axis on top, you can take the axis at the bottom, as long as the axis is one of the extremity. I made an important point now here. Why? Because if the axis is not at the extremity, then some moments will be in one direction, others will be in the opposite direction. Then the algebraic sum comes. That is why, beta, in the older ships, initially you remember, these particulars, longitudinal particulars, were given from midships. But then they realized it's creating confusion. Some moments are by head, some are by stern. So they said shift everything to the after perpendicular. For kg, you've gone to the extremity keel. There cannot be any moment on the other side of the keel. So a suitable axis, a convenient axis, is an axis which is one of the extremities. And which extremity should we prefer? We should prefer the extremity about which the results are required. Is that clear, beta? Is that clear now?
Yes, sir.
Gurmeet, clear? Danny, clear?
Yes, sir. Clear, sir. Thank you.
Okay, fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now I'll skip this question. I'll skip this question and take you to the next one. We'll come to this question after we introduce rule 2. Let's go to this question. The half breadth of a transverse watertight bulkhead. Now, guys, pay attention to everything and please interject anytime when you have doubt. Half breadth of a transverse watertight bulkhead at 2 meters intervals. Obviously, H is 2 meters in this case also. From top. Now, pay it, and they are given from top. Unlike the last question, they were given from bottom. Okay, so pay attention to the question carefully. Secondly, these are half breadths. They are not the full breadths. Guys, whenever these half breadths are given, what does it mean? That the other half is the mirror image of it. That means the full breadth will be double of this. Okay. Now, guys, people can work with half the breadth also and double up in the end and gain it. But for phase 1, phase 2, I'll change the little bit. So when in phase 2 you come, I'll change the thing a little bit. But in phase 1, whenever you have half breadths, these are called as half ordinates. Half ordinates. or semi-ordinates. When they are given half, they are called as semi-ordinates or half ordinates. Whenever you have half ordinates, please double them up at the beginning itself and close the issue. Understood? Have you understood what I said, guys? Whenever half ordinates are given, please double them up, make them full, and solve with the full ordinates. Don't keep them half for the last, because in exam you will forget, you will mess it up. There is every possibility of making mistakes. So to minimize the chances of error in phase one, it is strongly recommended that half ordinates are made full at the beginning and the question is solved thereafter. Is that clear, beta? Clear?
Yes, sir.
Clear, sir, clear.
Then below the lowest semi-ordinate, you see, that is 3.8, is a rectangular appendage. Appendage is a portion where the curvature has changed, where there is a sudden change in the curvature. So there is an appendage which is rectangular in shape, 7.6 meters in breadth and 1 meter in height. It is not half the appendage, it is full appendage. Find the total area of the bulkhead and the distance of its GC from the bottom of the appendage. Okay. There are 1, 2, 3, 4, 5, 6, 7. There are 7 ordinates. Is rule 1 applicable to 7 ordinates, guys? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Odd number.
Yeah. So be careful now. And anybody has any doubts, please interject. Even if you have a problem with, you'll get some firing from me, but don't go into hiding. You need to be in discussion. Okay. Now, guys, I've told you one thing. If half ordinates are given in phase one, please double them up and finish off the issue. Yes, somebody had a question, beta?
सर इन दिस क्वेश्चन जैसे सेमी ऑर्डिनेट्स ऊपर दिए हुए and सर नीचे अपेंडेज दिया हुआ तो दैट अपेंडेज इज पर्टेनिंग टू हाफ ऑफ द बल्कहेड या फिर कंप्लीट
No,
बल्कहेड के नीचे
no. It doesn't say. It doesn't say. It's a full appendage. It's full appendage. Okay.
ओके सर
So that's where the problem will come. If you take the upper part half and full appendage, then it's going to mess it up. So it's better that you take the full bulkhead into consideration. Again, I'll help you with the diagram. Again, maybe one more question after this, and then I'll hand over the lead to you. Guys, this is the curvilinear part of the bulkhead. 7 ordinates. I have made them full. Basically, what has he given? He's given you half of it. The other half is a mirror image. It is understood. They are given from top. So the top full breadth will be 21.2 meters. Next one will be 20 meters. I'm doubling them up. 18.6, 16.6, 14.2, 11.4, and 7.6. Is this part of the bulkhead clear to everybody, beta? Any questions on this? Please let me know, because we should not go back and forth, right? Is this okay? Up to this place, okay?
Yes, sir.
Yes, sir.
Now, below the lowest ordinate, now it's no more semi-ordinates. Yeah, I've already made them full, so I don't care whether they were given half or not. Is a rectangular appendage. So this is the rectangular appendage below it, which is 7.6 meters wide and 1 meter high. This is the full bulkhead, guys. This full thing up from here to here, this is the bulkhead. Understood? Is that clear?
Yes, sir.
Is it clear, beta?
Yes, sir.
Guys, any questions on the diagram? Please let me know if anybody has any clarity required on the diagram. Now, this area has two distinct parts. One part has a curvilinear shape. It's formed by the curves. And one part is a regular geometric shape. Obviously, we'll have to calculate both the areas separately and add them. So let us say we call this area 1 and this area 2. Now, can we calculate area 1 by Simpson's rules? Yes or no, guys?
Yes, sir.
Yes.
Can we calculate area 2 by simple mensuration formula of rectangle? Yes or no? Correct? And if I add both these areas, will I get the area of the full bulkhead? That will be my one answer. Yes or no, beta? Am I right? Class,
Right,
am
sir.
I okay? Okay. I'm just breaking my problem to calculations and then look at the question again. Find the total area of the bulkhead and the distance of its GC from bottom of the appendage. Danny, which axis should I prefer to take? As I said, you can take any axis. It's a game of moments. But the choice of axis is being governed by your convenience. So Danny, which should be my preferred axis now in this case?
Sir, down axis.
Bottom of the appendage, correct?
Yes, sir, correct.
Okay, very good. So I take this as my preferred axis. Is the diagram clear to everybody? Now, what do I need to calculate? I'm telling you now. I will calculate four things. I'll calculate area 1 and I will calculate the distance of geometric center of area 1 from XX. I will calculate A2 and I will calculate the distance of area A to GC from XX. Now, once I have these four things with me, guys, I'm sure all of you would agree with me. Total area will be A1 plus A2. Am I right? Yes or no? Correct, class? Correct?
Yes, sir.
And my distance of the geometric center of the combined area, guys, a while back in the class, a little while back in the class, I had drawn this thing of done this sort of a thing. Y, one area and two area. Do you remember A1 and A2 when I was doing? Yes or no?
Yes, sir.
How did I calculate the distance of the GC of the full area from YY? How did we calculate it? A1 into its liver plus A2 into its liver divided by A1 plus A2. Yes or no, beta? You remember this discussion? Yes or no?
Yes, sir.
If you don't remember, let me know what is the issue. Guys, when you know that the ship has two weights and you want to find kg of the ship, what do? W1 into kg1 plus W2 into kg2 upon W1 plus W2. Correct? Am I right? Yes or no? Correct?
Yes, sir.
Exactly the same thing is being used here. Distance of the geometric center of the full bulkhead from XX will be A1 into D1XX. This will be the moment of area 1 about XX plus moment of area 2 about XX. This will become the moment of the full bulkhead about XX divided by the total area A1 plus A2. That will give me the second answer. Yes or no, beta? Please let me know. Don't worry about the calculations. First, conceptually, be in agreement. If you have any doubts, please let me know now. Bolo bhai, class, is it clear? Guys, anybody has any questions? Because see, this will keep coming and again in the questions. Then after four questions, don't suddenly take me back and say, I'm ready to invest another few minutes here. If there's any problem, let me know. Is that clear to everybody?
Yes, sir.
Yes, sir.
Again, let me just say, if this is the ship and it has only two weights and the ship's hull weight is negligible, and there is a W1 here whose kg is kg1. There is W2 here whose kg is kg2. How do you find the kg of the ship? You take the vertical moment of W1, that is W1 into kg1, plus W2 into kg2 upon W1 plus W2. I'm sure this all of you are comfortable with. I'm sure, right? If there are
Yes,
only
sir.
two weights on the ship, right?
Yes, sir.
So what has happened? Instead of W1, you have area 1. Instead of kg1, the liver of W1, you have the liver of area 1. You have A2, you have D2, and you have, instead of W1 plus W2, you have W1 A1 plus A2. Can you now strike the similarity, guys? Yes or no? Clear, guys?
Yes, sir.
Okay. Guys, if you get stuck in this, then you'll have problems continuously. If you please let me know if there's still any issues, because this is the first class. There is absolutely no problem, no pressure on me. I can always take one more extra class. It's okay. Now you see XX. Now area H is 2 meters. Let's calculate area 1 by rule 1. Guys, tell me, which ordinate would you like to write first based on my last question input?
7.6, sir.
7.6.
Very good. Very good. The one closest to the ordinate, if we start writing levers, will be easier. Very good. Please, in your register, make the column, put the Simpson's multipliers by yourself, then I'll show you can match it. You don't have to speak it out. Put the Simpson's multipliers for rule 1 against all the 7 ordinates. Done?
Yes, sir.
Yes, sir. Done.
Is it so? 1, 4, 2, 4, 2, 4, 1. Right, guys?
Right, sir.
Now we'll come to the liver part. Look at the diagram. Did I say in the last class that every time we must take a multiple of h? Did I say so?
Yes, sir.
No,
Did
sir.
I say so?
No, sir. No, sir.
Did I
Kind of on
say
the
so that you should take always multiple of h? No. I said whether I take multiple of h or I do not take of multiple of h, it has to be driven by my convenience and comfort, right? Yes or no?
Right.
So guys, look at this diagram and tell me, look at the diagram. Levers will come from the diagram. What do you think is the liver for 7.6 meter ordinate from XX?
1H, sir.
1
Sir,
H.
H by 2, sir. 0.5 H.
Plus G.
0.5 H.
See, so
Sir,
when it is becoming so complicated, somebody saying 1H, somebody saying 0.5H, somebody saying something. If it is so complicated, should I indulge myself into multiple of H? Should I? No.
Sir,
Why will I?
1 plus 0 H.
But is that causing convenience to me or discomfort to me? Tell me.
1, sir. Only 1.
If I take it as 1 meter, is that easier for me, or taking it as 1 plus 0h or whatever you are saying? Is that more convenient? Which one is more convenient here?
1 meter.
1.
1.
Absolute number is more convenient here. Yes or no? Correct? Am I right, guys?
Yes, sir.
Okay. So as I said in the last class or last question also, liver does not have to be multiple of h compulsorily. Whether you take it multiple of h or not, you are taking it as multiple of h to simplify things for yourself, to keep your calculations down. But if it is complicating your calculations, we'll abandon this multiple of h. Why should I get hooked onto it? It is if it is not serving the purpose. So in a question like this, I don't think multiple of h is going to make anything easy for us. It's rather going to make it more difficult and complicated. So in this question, for sure, I will dump the multiple of h concept. Now tell me, what will be the absolute value of liver for 7.6?
1 meters.
One.
And for 11.4, look at the diagram.
3.
Three
And
meters.
then 5, and then 7, and then 9, and then 11, and then 13. Yes or no? Correct?
3, 5.
Correct? Guys, please don't have so much of fixation on being multiple of h or not. I said in the last question also, if somebody did not want to take multiple of h, it was fair, no issues. I had written in pen the other levers. Okay, so whether you take multiple of h or not, it has to be convenient to you, then you take multiple of h. If it is not making it convenient, just leave it here. Why unnecessarily drag it, live with it? And we get product of moment. Now you see some more things I'll draw your attention. POA1, this is the product of area 1. This is the product of moment of area 1 about x. 1 is also there. It is not for the full area. So if you name your column headers clearly, you will not make mistakes. This will be SOP1 here, and this will be SOP moment 1 here, and this is not after perpendicular, my mistake. This is XX. Sorry, my mistake. This is XX. Is the table clear? Please review it, especially Gurmeet, Danny, and others. Please review it. Let me know if there is any concern. I can go back and explain.
सर ये एच वाला पार्ट सर समझ नहीं आया. अगर 1 मीटर हाई है तो 2 मीटर इंटरवल पे तो स्टार्टिंग व्हाई नॉट फ्रॉम 3 सर?
पहले तो ये बताओ, what did I tell you? What is liver? When I was explaining what is liver, if you recall what is liver, you'll get the answer. What is liver that I told you? What is liver?
सर डिस्टेंस
हाँ, वो सही
सर
बोलना इंदर. मैंने जो शुरू में लिवर समझाया था वो क्या था? What was liver?
distance at which the body is rotating.
Distance of what, yaar? Distance of what, yaar? Distance of what?
Perpendicular distance of the
Perpendicular distance of centroid of area, volume, mass, weight.
From the reference axis. So इंदर क्या है? Selective listening है क्या? इंदर,
नहीं सर नहीं.
Sir, one
you
doubt.
want to only listen what you want to hear, is it? So now, since people have told what liver is, so we are talking of liver of 7.6. Where will be the center of this ordinate? Indar, where will be the center of 7.6 ordinate?
Sir 1 meter.
Are, where will be the center? It will be the midpoint of the ordinate.
Midpoint.
And what will be the distance of that center from the XX?
1 meter.
Where will be the centroid of 11.4 ordinate?
Plus 2 हो जाएगा सर, 2 meter interval पे.
So what was your question then?
Clear.
तो जब तक तेरे को डोज नहीं मिलती तेरे को क्लियर नहीं होता. आधी बातें सुननी होती है. Anybody has any questions on livers now? Is that clear, बेटा?
सर एक और क्वेश्चन था.
हाँ, ये tell
सर
me.
सर ये जो अपना जो कर्व पोर्शन है हम सिर्फ वो कंसिडर करके लेंगे एंड बाद में उसमें 1 ऐड करके तभी भी सेम ही आएगा ना?
Sorry, बेटा.
जहां से हमें ऑर्डिनेट्स दिए हुए हैं, if we
No,
take
you can take it. Beta, it is a game of movement. You can take the axis here. This is what you're saying. Or you can take the axis here. You can take anywhere. But what I'm saying is, why not stick to the axis about which results are required? Otherwise, in the end, if you add to make corrections, then you'll make mistakes, right? Okay. Ankit, you can take any axis as long as you're comfortable with moments, right? Understood, beta?
yes sir.
You are absolutely right. If you take the axis here, then levers can be 0h, 1h, 2h, and so on. But then you'll get the distance of the GC from that. But you want, your question will want from XX, right? Your question doesn't want from there, right? So you want to do it there, you can do it. No issues. No issues. Okay? Okay.
सर मेरा
Now,
भी यही
guys,
डाउट
हाँ, क्या डाउट था? What was the doubt, beta?
यही डाउट था सर. It is clear now.
No, you can take it here, but see, what I am telling you are the, by experience, the methods which will reduce the possibility of error subsequently. That's all I'm saying. Otherwise, if you are comfortable with moments, you can take whichever axis you want and you can play around with it. Right? There is no hard and fast rule that this should be the only axis and there cannot be another axis. This is not what I said, right, beta? Correct? So you can take another axis if you want, but as long as you're comfortable. But my experience says in the exam pressure, if the axis can be the one from which results are required, chances of last minute miss out and mishaps will be lesser. That's all I'm trying to say. That's all I'm saying. Otherwise, it's up to you. Okay. But at the same time, let me reverse the thing. That if I am forcing upon you another axis, then you should be comfortable with that also, because that will be the sign of the fact whether you're comfortable with the concept of moments or not. See, today, if you tell me, sir, work around with the top axis about the bulkhead top, I'll work around, because why? I'm comfortable. If somebody says work about this axis, I'll work about because I'm comfortable. So if I'm taking XX, then XX should not bother you. If it is bothering you, that means there is somewhere shakiness about the concepts. Is that clear, beta? Axis can be changed anytime. No problems. Okay, guys. Can you now please calculate A1 and give me the answer? What is A1 equal to?
190.933.
190.933. Please calculate A1. Everybody to calculate coefficient multiplied by common interval multiplied by SOP A1. Rule 1, coefficient 1 by 3, common interval 2, SOP moment 286.4. You are saying 190.933 meters. Is that a meter square? Am I right, beta?
Right, sir.
Yes, sir.
Everybody is good with it?
Yes, sir. Yes, sir.
We'll also calculate D1XX. That will be equal to moment 1 about XX divided by area 1. Now, some of you will say, can we divide SOPs with SOPs? Yes, but I will stick to very fundamentals, because in rule 3, you can have problem otherwise. It will be 1 by 3 into common interval into SOP moment. This time it is not a multiple of H, it's a whole number. It's a pure number into 2 into 286.4. This will get cancelled. How many meters is this, beta?
7.826.
7.826. 827.
827, okay. Look at the diagram and tell me what will be A2 equal to. It will be 7.6 into 1 equal to 7.6 square meters. Am I right, beta?
Yes, sir.
Right, sir.
What will be D2XX?
0.5.
0.5.
Half.
That will be the distance of the geometric center of the area. Where will be the geometric center? Intersection of diagonals. What will be the distance from there? 0.5 meters. Now we are good to get the answer. Total area A will be A1 plus A2. And when you add them, I'm picking up the answer from top. It will be 198.533 meters square. That is this plus this, right? Then we want the distance of the geometric center from XX of the whole area. DXX is for the whole area. It will be A1 into D1XX plus A2 into D2XX. I've already explained this, but again, I give another opportunity. If anybody has any doubts on this, please let me know. I can again explain it. And when you put these values, you should be getting this answer. I'm picking up from here by rule 1. Is that clear, beta?
Sir, I have one doubt, sir.
हाँ बोलो बेटा.
Sir, we are taking the axis already at the bottom of the appendage only, no, sir.
Yes,
Then
correct.
why we are again calculating dx using the formula?
Because your whole bulkhead is A1 plus A2, right?
Yes, sir.
Correct.
Yes, sir.
What is D1XX? D1XX is the distance of the geometric center of this blue shaded area only from XX, right?
Yes, sir.
And D2XX is this yellowish orange shaded area 0.5 meters from XX, right?
Yes, sir.
Now you want to get where is the geometric center of this full area. When you add these areas, what is the geometric center of this full area, which now I am shading in red up to this place, this area?
Yes, sir. But we are adding that 1 meter, no, sir. If we are
No. Which 1 meter?
Sir, in the when adding for the liver, we are adding that 1 meter also, no, sir. We are
No,
not taking.
No. Where? Which axis are you talking about? Which axis have you taken?
Sir, from x-axis for the area A1, we are calculating the D1, sir. That D1.
No. When you take livers, you are taking the livers of the ordinates of A1, correct?
Yes, sir.
So that
okay,
will
sir.
give
Understood.
That will give you the distance of the GC of A1 only, na beta?
A1 only. Yes, sir. Understood. It will give the only GC of A1.
A1 from
because,
XX.
from XX. Okay, sir.
Right?
Understood.
Yeah.
Yes.
Is it clear, beta? Okay, class. I'll show you these two. I've seen the watch. Don't worry, I'll not unnecessarily drag it. I'll take 3 more classes if usually I finish up on 3, but if it has to drag to the 4th one, let it never mind. Don't worry about it. Guys, what I expect you to do is I will not load you with rule 2 right away. What is my expectation from you today? Simple expectations. 1, those who have not done question number 3 and question number 4 of dry docking grounding assignment. Second, rule 1, applicability criteria. When does it apply? 2, Simpson's multipliers. 3, Simpson's coefficient. Okay. And then these 2 questions from the exercise. If you see these questions, let me just check on my phone. This is question number 2 of the exercise. The exercise has already been shared. That's the exercise from Captain Subramaniam sir's book. That's the exercise from Captain Subra. I've shared with the answers. Our answers are at the end. So if you don't have a book, don't start running around. It's question number 2 and question number 1, 2, 3, 4, 5, 6, 7. Okay. And question number 3. Question number 2 and question number 3 of Simpson's rule exercise is what we have done. Have a good look at it. But when you are having a look at it, please pay attention to the following things. 1, diagram should be suitable. Number 1. Number 2, choice of axis should be smart. Guys, when I'm saying it should be smart, it doesn't mean other axis cannot be taken. It automatically implies you can change the axis, but that may not be a smart one for your working. That's all I'm saying. 3, recall the definition of lever. It is the perpendicular distance of the centroid of the ordinate from the reference axis in context with the Simpson's rules. In context with the Simpson's rules, It's the distance, perpendicular distance of the centroid of the ordinate from the reference axis. Okay. Fourth, liver, multiple of h, not multiple of h. Driven only by convenience. So there is no hard and fast rule how the liver should be taken. You can take absolute numbers, you can take multiple of h. Whatever in a given scenario makes my job easier, I will take that as a liver. So there is no hard and fast rule how the liver should be taken. Is that clear, beta? So I hope I have not given you any impression that liver should be taken as multiple of h all the time, or should it never be taken multiple of h? It's your choice, what gives you comfort. Am I right, beta? Clear, guys?
Yes, sir.
Okay. Yes, sir. So please revise this. You can revise these questions. Questions are with you. And let me hear tomorrow again. The first 10 minutes, I'm ready to give again to revisit any of these concepts. But of course, there'll be some counter questions to you. Okay. So, but I'll be happy to answer any questions. And then tomorrow we'll pick up speed. Tomorrow I have a target of at least about 10 questions to be done. So tomorrow we have a target of about 10 questions to be done from the exercise, which will take us to 12th, 13th question. Okay. So let's meet tomorrow, guys, 17:30. Have your doubts consolidated. Dry docking and grounding. If you have problems in question 3 and 4, I'll attend to them. Somebody was saying his other answers are not matching. When we reach those questions, I'll be happy to look at those questions where there is a problem.
Sir,
Okay. Tell me, beta.
sir, can you please show the previous working last step, sir?
Let me see if it is there, beta. I don't know if it is there or not. No, I don't. I think I have deleted it, beta. Let me see.
Okay, sir.
I doubt. You can see this one. No, this will give you enough idea. You can take the steps of the first question. They will give you the direction. I'll write the further that one also. Don't worry. This is done. Is it okay?
Yes, sir. It is done, sir. Yes, sir.
Okay. Let me go to the third one.
सर मैं शेयर कर देता हूँ सर मैं शेयर
No,
कर
no.
देता हूँ मैं
कोई बात नहीं नहीं मैं इसको बता देता हूँ कोई बात नहीं चिंता नहीं करो It's okay. Don't worry. I'll do it again. You will calculate A1. You will calculate A1. A1 will be equal to 1 by 3 into 2. Those who want to sign out and can sign out. If you don't want to be part of it, it's okay. Perfectly okay, guys. I am not doing anything else. D1XX will be beta moment of area 1 about XX upon area 1. This will be equal to 1 by 3 into common interval 2 into SOP moment 2241.60 upon area is 1 by 3 into 2 into 286.40. 1 by 3 and this will get cancelled. You will get some value here in meters. Okay.
7.82.
Then that you can calculate. That's okay. Area 2. Area 2 in our diagram is a rectangle. So that will be 7.6 into 1. 7.62 square meters. D2XX from our diagram will be 0.5 meters. That doesn't need any explanation. Answer total area 1 plus A2. Answer is there by rule 1, 198.533 square meters. DXX, the distance of the geometric center of the total area from bottom is A1 into D1XX plus A2 into D2XX upon A1 plus A2, and this is equal to, you will get an answer of 7.546 meters. That's what you wanted, right, Pata?
Yes, sir.
You
Yes,
can
sir.
take this. Yeah.
Yes.
Clear?
Yes, sir. Clear. Thank you.
Yeah. Okay. Okay, guys. See you at 17:30 tomorrow. Bye.
Bye, sir.
Bye, Bacha. Take care. See you tomorrow.
Right, sir.
Bye,
night.
Bye,
Bacha.
sir.
Bye. 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 Good night.